So today we will discuss about load test on three-phase alternator. So to conduct the load test on alternator, so we need to have some apparatus. So first of all, we will look into the apparatus that we require. So if you see this panel, so this is the panel. So used to conduct the load test on the alternator. So here we have DC supply and we have one 3-point starter. So if you see the missions, so these are the cascaded missions, so on which we have DC shunt motor, and this mission is the alternator, and this is the exciter. So now, so in this experiment I will use this shunt motor, so which is coupled to the alternator. The mechanical input required by the alternator will be given by this shunt mission. So first of all I need to start the mission. So first of all, to start the alternator, so I need to give the mechanical input. So to start this shunt motor, I need to use this 3-point starter. So if you see the apparatus here, so here I have 1280 ohms and zero point 0.8 amperes, so rheostat. So this is kept in a field circuit. So and this is the exciter. So this exciter is used to give the required amount of the voltage for the field winding of the alternator. So here if we see, here there are 8 terminals. So here we have 4 terminals. So one, two, three, 4. These 4 terminals are the field terminals. I will short any 2 terminals, and for remaining 2 terminals, I will give the DC supply by using this exciter. So this exciter is used to excite the field winding of the alternator. So in the field circuit, to measure the field current, I am placing an ammeter. And if you see the alternator terminals, so by excluding these 4 terminals, field terminals, so if you see these 4 terminals, so one is R, other one is Y, and this is B, and this one is neutral terminal. So I will place a voltmeter across any two phases. So line to line voltage I am measuring. So I placed here a voltmeter across Y and B terminals, and here, so I am placing an ammeter. So in series in R phase, I am placing an ammeter in R phase. So from R, Y and B, so I am connecting these three phases, R, Y, B phases, I am connecting to the inductive load. So here if you see, this is the inductive load. So here we have total 6 terminals. So 3 terminals are shorted, and remaining for 3 terminals are given supply through a triple pole single throw switch. So this is the TPST switch. So I am giving alternator R, Y, B phases through this TPST switch to the inductive load. So by varying this wheel, so I can change the load. So I can apply the load by changing this wheel position. Now let us start the mission. So by giving the DC supply, so initially we need to follow some precautions. So the field rheostat must be placed in minimum position. This is a motor rheostat, so which is placed in F, which is placed in series with the F terminal. So I am starting the mission. So I kept this field rheostat in minimum position, and exciter also. So initially we need to keep at a 0 position. So I kept at 0 position. Okay. Now DC supply is applied to the DC supply came to these positive and negative terminals. Now I will move the handle of the 3-point starter. Then the mission will start run. Now the mission started running. Now I will measure the speed. Yes. Now the speed is around 1280 RPM. So I need to increase the speed. The rated speed is 1500 rpm. Okay. Now I will increase the speed by changing the rheostat position. So now again I will check the speed by using tachometer. So speed is not 1500 rpm, it is about 1450 rpm. Again I will increase the rheostat. Now I will check the speed again. Now the speed is exactly 1500 rpm. Now I will give the excitation. So slowly I will increase the excitation, field excitation, and the voltage. If you see the voltmeter reading, so voltage is generating in the machine. So I need to increase the excitation up to the 400 volts, as this machine is designed for 400 volts. So I used 600 volts terminal. So I need to increase up to 200 volts. That is 200 into 2, 400 volts. Okay, the voltage now is 400 volts. So if you see the ammeter, so which is placed in R phase, I connected ammeter in the R phase. So other terminal of the ammeter is connected to the load. As TPST switch was open, no load, under no load condition, ammeter is not showing any deflection. Now I will close the TPST switch. So immediately ammeter started deflecting and it is indicating around 1.7 amperes, and the voltage also so reduced to around here it is showing 186 into 2, so 372 volts. So voltage reduced to 372 volts, and I will start increasing the load. So I can increase the load up to the rated current. So see here, I am increasing the load. So the machine is designed for 7 amperes. So I can increase the load in steps. So I can initially place 2.5, and now I will increase the load up to 3 amperes. Stop. So now the load is 3 amperes. I can still increase the load up to 3.5 amperes. If you see the volt, yes, the ammeter reading is so 3.5 amperes load I applied, and the voltage is reduced. So now it is indicating around 134 into 2, so 268 volts. So voltage is slowly reducing. As the load is increased, voltage falls down. So like that, I can increase the load up to 7 amperes in steps. So this procedure to be adopted while conducting the load test by using inductive load. So now I am reducing the load. I am reducing the load. If you observe here, while reducing the load, voltage is again reaching to the rated voltage. Okay, now I will open the TPST switch. I am removing the load from the circuit. Now the see here rated voltage So 400 volts we obtained in the voltmeter. Slowly I will reduce the excitation. I will reduce the DC excitation. Voltage falls down. I will decrease the field rheostat and speed of the machine slowly reduces. So I will remove the supply by switching off the MCB. So like this we need to conduct the load test on alternator by using inductive load. Similarly I can place a resistive load also. So when we are using the resistive load, speed of the alternator slowly reduces. Speed of the alternator slowly reduces. So at every instant of the load, so we need to increase the speed. We need to match the speed up to the rated speed. But for inductive load, as and when I am applying the load, the speed of the machine won't get decreased. It will be stable. So conveniently we can apply the load. But this inductive load makes so much noise during the test, so we should not afraid of it because of its nature only. It will make lot of noise, so don't bother about that. So like this we need to conduct this test. So by using both inductive load as well as resistive load, and we can finally find the regulation of the alternator by conducting these two tests. Okay, thank you.